A molecule is the smallest particle of a pure substance that is capable of stable, independent existence. All molecules are made up of atoms, so this makes atoms to be tiny particles that constitute all matter. Whether you're working with a copper, solid, sugar, or a solution, a mixture solution of oil and water, all of these are made up of molecules, and molecules are made up of atoms. So, to classify molecules can be made up of different types of atoms. So, to know the classification, you do have to count the number of atoms in the molecule. A diatomic molecule is a molecule that contains two atoms, so we use the prefix di, di means two. A triatomic molecule is a molecule that contains three atoms, and a polyatomic molecule is a molecule that contains more than three atoms. Here we do have an example of three gas cylinders, and they do contain three different types of gases. So oxygen in there, oxygen does not exist as its elemental form, which is just O. When we say oxygen, oxygen is a gas, so oxygen is two O's. So it's a diatomic molecule. It's made up of two O's. So this one is going to be a diatomic molecule in there. It is a molecule because it is an O2. Carbon monoxide is a CO gas. It is made up as well of two atoms. So this one is a diatomic molecule as well. Carbon dioxide is made up of a carbon and two oxygens. So this is a three atoms. So we're going to consider this as a triatomic molecule. And sucrose is a sugar, and sucrose is made up of 12 carbons, 22 hydrogens, and 11 oxygens. So this is a lot of atoms in there. So this is why we classify sucrose as a polyatomic molecule. Also, molecules are classified based on the type of the atom that they are made up from. So, if all of the atoms are the same, then we're going to call this a homoatomic molecule. Like, for example, oxygen. Oxygen is a diatomic and it is a homoatomic at the same time. Okay. And then you have heteroatomic molecules. These are molecules that contain two or more different kind of atoms, like carbon monoxide, carbon dioxide in there, like sucrose, for example. All of those are considered to be heteroatomic molecules because they do contain two or more different kinds of atoms. Classify the molecules in each diagram using the terms diatomic, triatomic, or polyatomic. And then we need to classify them also based on the terms homoatomic and heteroatomic. We do have this chemical reaction where we are starting with H2O2. H2O2 is hydrogen peroxide. And as you can see, it's changing into two different substances. So this reaction, we're going to call it decomposition, where the hydrogen peroxide is decomposing into water and into oxygen. So to start with the hydrogen peroxide is made up of two hydrogens and two oxygens in there. So this is actually four atoms. So we're going to call this polyatomic. So hydrogen peroxide is polyatomic. The atoms in the hydrogen peroxide are not the same. So this is considered to be heteroatomic as well. Okay. For the water is made up of three atoms, two hydrogens and an oxygen. So we're going to call this a triatomic. And same thing, the hydrogens are different than the oxygens. So this one is going to be a heteroatomic. Oxygen on the other end is two atoms. So it is a diatomic. And the hydrogens are the same. So it is homoatomic. Elements and compounds. So pure substances are pure substances can be either elements or they can be compounds. So, if pure substances are elements, then these are made up of atoms that are all the same. Okay, like for example, all the gases that you see, all these diatomic gases that you see, like nitrogen, oxygen, um, hydrogen, for example, I three. I3 is not a gas. So all of those are considered to be homoatomic molecules. So these are considered to be homoatomic, and these are molecules in there. So these are homoatomic molecules, and these homoatomic molecules, they are made up of the same atom. Those we do call them elements. So those are called elements. So in addition to the elements in the periodic table, like aluminum, like copper, like carbon, we're going to talk about all of those in the next chapter. Those diatomic molecules are also considered to be elements, and the reason why, because they are made up from the same atom. Pure substances can also be called compounds, and these are made up of combination of atoms of two or more elements, like CO2, water, CO, sodium chloride. Sodium chloride is a table salt, NaCl. This is a table salt which is made up of sodium atoms and chlorine atoms. So these are ions that you combine them together and they make the table salt, which is the sodium chloride. This is considered to be a heteroatomic molecule. So all of those are heteroatomic molecules. Let's have some examples in there. S8. So what is S8? S8 is definitely, since it is a molecule that is made up of 8 sulfurs, and the sulfurs are the same, you guys. Okay, so since they are all the same, I no longer will call it a compound. It is not a compound, it is an element in there, because it only constitutes of the sulfur element in it. Although we have 8 sulfurs, so this is going to be an element that is a polyatomic. It is polyatomic because of the number of sulfur atoms in there, which is more than 3. So this is why we call it a polyatomic molecule. CH3OH, and there is made up of carbons, oxygens, and hydrogens. So when we want to classify the molecule, count all its atoms, okay? So when we count all its atoms in there, you can easily see that it is made up of 1 and 3 hydrogens and oxygen and the hydrogen. So this is 1, 4, 5, and 6. It's made up of 6 atoms, so that will classify it as a polyatomic. The atoms in there are different. So the carbon is different than the hydrogen is different than the oxygen. So this is why we are going to classify this as a heteroatomic, and it is a polyatomic at the same time. Classification of matter. So matter refers to all kind of materials that make up the universe. And matter is classified into pure substances and mixture of 2 or more substances. So if we consider pure substances, they are always homogeneous in composition. A pure substance has a constant composition and a fixed set of chemical and physical properties. Example, pure water, because pure water always going to have the same proportion of hydrogen and oxygen. Water is made up of 2 hydrogens and an oxygen. If you get a glass of water is made up of H2O, and it is the same proportions of hydrogens and oxygens across the board. Oxygen and it's the same proportion of hydrogen and oxygen. It freezes at a specific temperature as well. So this is why we say that water is a pure substance. There's no other substance that is in the water. So this is why it is a pure substance in there. Another example is ammonia. oxygen, all of those, they do have the same proportions, and they do freeze at a specific temperature. So this is why we call them pure substances. On the other hand, the mixtures always contain two or more substances, and they may be either homogeneous or heterogeneous. It depends on the type of the mixture in there. Mixtures, they do vary in composition and they do vary in properties. Let's have an example. A mixture of table sugar and water. So what is that? Take a beaker or a cup, put some sugar in it, add some water in it, dissolve. All the sugar will dissolve in water, right? So you're not gonna have anything in there that simply precipitates. So since you're forming a homogeneous solution, we're gonna call this a homogeneous mixture. So this one over here will be a homogeneous mixture because the mixture can be either homogeneous or heterogeneous. So a homogeneous mixture is a mixture where everything is dissolved in it. Like for example, if you buy a can of soda, I mean, you don't have anything that's precipitating in there, so we're gonna consider this as a homogeneous mixture. Um, a glass of water, for example, can contain one, two, three tablespoons of sugar. The properties of sweetness, for example, would be different for the mixtures with different proportions. So you have to pay attention to that. But it's still, as long as your solid is dissolved in the solution, then that will be considered a homogeneous mixture. If you take a sample of that mixture, because we're calling it homogeneous, right? So if you take a sample of that mixture in there, it will have the same properties. It will have the same physical properties. It's gonna have the same taste in there. On the other hand, if we're talking about heterogeneous solutions, these are solutions that are made up of different properties throughout the sample. And the properties depend on the location where the sample is taken from. So, for example, ice and water. So, this is a heterogeneous solution because we know that the ice floats in the water, right? So, if you want to pick up the ice alone, the ice has different properties than that of the water. Same thing wood. Wood elements and compounds in a piece of wood are not mixed evenly throughout the wood. So wood is considered to be a heterogeneous mixture, not a solution. It is a mixture. Blood is a solution, though. So blood is a heterogeneous solution, which is made up of blood cells and the plasma. So these are two separate things that you're combining them together. So it is considered to be a heterogeneous solution. The blood cells and the plasma, they do not actually, they are not miscible with each other. So this is why it's a heterogeneous solution. Oil and water, same thing. Oil and water, these are two phases. Oil, it does not dissolve in water. Oil floats on top of the water because oil has less density than that of the water. So these two are considered to be heterogeneous solutions. So heterogeneous solutions, these are solutions that they don't mix with each other, okay, or components of the solution that don't mix with each other. In contrary with the homogeneous solutions, these are solutions that are in perfect harmony and they do mix with each other. Let's have an example. So the following shows the structure of fructose. Fructose is a sugar. It's a fruit sugar. It's very sweet. It's the sweetest type of sugar. So we're gonna classify fructose. We know, see, this is a molecular model of fructose, and the black circles are carbons. The red ones are oxygens, and the white ones are hydrogens. So you can easily see that this is a compound which is made up of carbon, it is made up of oxygen, and it is made up of hydrogen. It is not an element because if it was an element, then it will be made up of just one type of an atom. It's a compound because it's made up of more than um, one type of atom. Okay. It is not a mixture. When we say mixture, this means that it is dissolved in the solution. So definitely it is not a homogeneous mixture and it is not a heterogeneous mixture. Classify the following water sample as an element, compound, homogeneous mixture, or heterogeneous mixture. You can see here the yellow spheres. The yellow spheres are uniformly distributed in the solution, right? So that is going to be considered a homogeneous genius mixture. It's like a soda solution in there. Okay, soda solution does have components that are dissolved in the water. So that is considered to be a homogeneous mixture. On the other hand, for this one here, the yellow spheres are not uniformly distributed. So you can see that the yellow spheres like are floating on the top in there, and then you have the whole liquid sample. So this is considered to be a heterogeneous mixture. So this one is a heterogeneous mixture. Okay. Um, so when sulfur, an element, is heated in air, so far, if you have any reaction, I'll write the reaction for you. Later on, we'll learn how to put the reaction together, and we'll learn how to write the structure of the molecules as well. So sulfur is heated in air. It combines with oxygen. So sulfur combines with oxygen. So S plus oxygen. Sulfur is a solid. Oxygen is a gas. Okay. So solid, we're going to represent it by an S. The gas, we're going to represent it by a G in there. And you're going to form sulfur dioxide. So it says sulfur dioxide. That is going to be a gas as well. Classify sulfur dioxide as an element or as a compound. Sulfur dioxide is made up of more than one element, in there, or more than one atom. It's made up of sulfur and it's made up of two oxygens. So that is, or sulfur and an oxygen, it's made up of a compound. It is a compound. And that compound is made up of how many atoms? It is a triatomic because it is made up of sulfur and two oxygens. So this is the total number of atoms in the structure. Three. Are the atoms the same? No, they are not. So it is a heteroatomic. So as a summary, matter is classified into a pure substance or a mixture. Pure substances can be either elements or compounds, and elements and compounds, they are made up of molecules in there, and molecules are made up of atoms, similar to heterogeneous mixtures and homogeneous mixtures. They are made up of molecules, and molecules are made up of atoms. So actually, atoms, they do constitute all matter in there. Let's have another example giving the following reaction. Classify hydrogen, F2 and HF. So I'm combining hydrogen gas and I am combining the fluorine gas in there. So here you go, I'm combining hydrogen gas, I'm combining the fluorine gas, and I am forming HF in there, which is actually hydrogen fluoride, which is again a gas. So all of those are considered to be pure substances. The hydrogen, the fluorine, and the HF, they are pure substances. Why they are pure substances? Because they uh, they constitute, or they have constant composition and a fixed set of chemical and physical properties. So here, hydrogen, fluorine, and HF. So all of those are pure substances in there. Elements. So which ones are elements? The diatoms are elements. So hydrogen and the fluorine, these are considered to be elements. They are pure substances and they are composed of homoatomic molecules. On the other hand, HF, it's made up of a hydrogen and a fluorine, so this one is going to be a compound.